So our next topic is going to be functions. Function na a relation f from set A to B. Okay, for example, instead of reading the whole definition, I'll do one thing for you. I'll draw your A and B. Okay, so for example, if you have 1, 2, 3 here and A, B, C here. So what is the function? First relation na when we see what is the relation, we see that if the arrow mark pota, we tell that 1 and A are related. When you put an arrow mark like this, you say that 2 and B are related. Correct? So how is your ordered pair going to be 1, A, 2, B? And for example, if this is the case, it is going to be 3, C. So these are all going to be your relations. When is a relation a function? Ella relations are function kadayadu. So when is a relation going to be a function? Only if, what is written here, if every element of set A has only one and only image. One image mattum dhaan irukku. So 1 has only A, 2 has only B, 3 has only C. So this is a function. This is a function. For example, if 1 is also paired to B, you see that there are 2 arrows coming out of 1, which means there is no one and only image. Correct? You have 2 images. You have A and B. So A is the image of 1 and B is the image of 1. So you have 1, A and 1, B. So in that 1 has 2 images, which means this is not a function. This is not a function. You should only have one and only image. One and only image na in that 1 ku A mattum 2 ku B mattum. For 3 only C. Correct? So there should not be any repetition of images. Correct? So it is easy. Just remember that you should never have 2 or more than 1 arrow from the left hand side. Okay, so in the left hand side you should only have 1 arrow and 1 arrow. Okay, one line going from the left hand side to the right hand side. This is just an easy way to remember. Okay, easy and okay, so this is going to be a relation. We'll just go through the definition once. The relation f from a set A to a set B is said to be a function if every element in set A has one and only image in set B. Okay, understood? If f is a function from A to B, A, B belongs to f of A equals B, where B is called the image of A, correct? And other way around, it is going to be the pre-image. If you have 1, A is the image of 1, which means 1 is the pre-image. Okay, so whatever you have on your left hand side, these are all going to be your pre-image. Whatever you have on your right hand side, these are all going to be images. Okay, clear? So the function f from A to B is denoted as A arrow mark B. So this is how you define a function. This is just way of representing. Okay. Now, example 10. Let n be a set of all natural numbers and the relation R is defined on n such that R equals, this is called the set builder form. Correct? We have learned relations. Now this is functions. So now R is x, y such that everybody set of all ordered pairs. So you call this as set of all ordered pairs x, y such that y equals 2x and x, y belongs to n. Okay. So we have y equals 2x. So this is the relation. They are asking for the domain, codomain and range. Domain is going to be set of all permissible inputs. Range is going to be set of all permissible outputs. Codomain is going to be set of all possible outputs. So B la ennala irukko adu ellame codomain. Okay, you guys remember this? Please watch my previous videos if you don't remember. So now y equal to 2x. So ipo x ku y ku values potte varala. Just few examples. Okay. So when x is 1, y is 2. When x is 2, y is going to be 4. When x is 3, y is going to be 6. Okay. So how does your diagram look like? 1, 2. They've given that x, y belongs to n. Correct? So it is going to be all real numbers, all natural numbers. So 1, 2, 3, 4, 5, 6, 7 and so on. 1, 2, 3, 4. 5, 6, 7, 8, 9 and so on. So what is the mapping going to be? 1 is mapped to 2, correct? Then 2 is mapped to 4, 3 is mapped to 6, 4 is mapped to 8, 5 is mapped to 10 and so on. So let me write the ordered pair. So what do I have? 1, 2, 2, 4, 3, 6, 4, 8 and so on. So this is going to be your relation. Correct? So this is going to be your R. So what is your domain going to be? Domain is going to be all permissible inputs. So all permissible inputs. Enna possible? You have 1, 2, 3, 4 and so on. So this is going to be set of all natural numbers. This is your domain. Okay. Now what is your range? Your range is going to be set of all permissible outputs. So outputs are 2, 4, 6, 8, 10 and so on, which means you have all positive even numbers. Correct? So you have 2, 4, 6, 8 and so on, which is going to be all even natural numbers. Okay, so this is how you can write, or you can write it as 2k, where k belongs to natural numbers. Okay, in a very short form. Then what is your codomain? Codomain is going to be all possible outputs. All possible outputs. Now what you see here, all natural numbers. Okay, so codomain is all possible outputs. Possible ko permissible ko difference theriyano. Okay, now we have a new question. Is this relation a function? Is this relation a function? Now you should only have one image. So for 1 I only have 2. For 2 I only have 4. For 4, I only have 8. So for every pre-image 1, 2, 3, 4, I only have one image 2, 4, 6, 8, 10 and so on. Correct? I see that there is only one arrow mark going from each and every number. Shortcut. There is only one arrow mark going from each and every left hand side set. Correct? So this is a function. So every reason your reason should be each element in A has only one image in B. Hence, this is a function. Okay, as simple as that. Okay, very, very easy. Please copy. Example 11. Examine each of the following relations given below and state in each case giving reasons whether it is a function or not. You have to check if this is a function or not. So, for first case, you have 2, 1, 3, 1, 4, 2. So, what are all my set A? It is going to be 2, 3, 4. So, I'll do this. Okay. And what are all my set B elements? It is going to be 1, 1 and 2. You do not repeat it. So, it is 1, 2. Okay. Now, how am I going to map it? 2, 1, 3, 1, 4, 2. So on the left hand side, I see that from each element there is only one arrow mark. In that one arrow mark, but that doesn't matter. Correct? Each and every element has only one pre-image. Correct? So how can you write this? For 2, 3, 4, you have 1, 1 and 2. So there is no repetition. Okay, so this is a function. It is a function. Same reasoning as before. Please write it. Okay, it is a function because it has only one image. Okay. Second subsection, what do I have? 2, 2, 2, 4, 3, 3, 4, 4. So what are all my set A elements going to be? 2, 3 and 4. Correct? The first element from the ordered pair. And what are all my set B elements going to be? 2, 3 and 4. 2, 4, 3, 3, 4. So that this is how it's going to be. Now I have 2, 2, 2, 4, 3, 3 and 4, 4. I see that I have two arrow marks from the element on the left hand side. So, in the tabular column, I can write 2, 3, 4. 2 is mapped to 2. 2 is also mapped to 4. 3 is mapped to 3. 4 is mapped to 4. I see that there are two elements, two images. Correct? Na? There are two images, but there should only be one image. You understand? So, I have two images here. 2 has element 2. Element 2 from set A has two images. Hence, it's not a function. Okay? So instead of the arrow mark, you can simply draw this tabular column. It will be very, very clear. You will not get confused. Enga arrow mark varno and the confusion la illama. You can simply do a tabular column. Wherever there is repetition of elements, it is not a function. Okay, there should not be two images, more than one image. Okay, third subsection. What do I have? 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 5, 7. So what are all my elements from set A? It is going to be 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. Okay. So what are all my elements in set A? It is going to be 1, 2, 3, 4, 5, 6. And set B, 2, 3, 4, 5, 6, 7. I already see that there is no repetition. So 1 is mapped to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6 and 6 to 7. So there is no repetition. Tabular column it is the same thing. 4, 5, 6. So for 1 it is going to be 2, for 2 it is going to be 3, 3 is going to be 4, 4 to 5, 5 to 6, 6 to 7. So I see that there is no repetition. So there is no repetition, so there is only one image, which means this is a function. Okay, please copy. Definition 6. A function which has either R, we are going to learn about real valued function or real function. When you talk about real valued function, the output is going to belong to all real numbers. Input not necessarily have to belong to real numbers. Output mattu real number input this is real valued function. Only output belongs to real numbers. Real function what is only real function? Both input and output belongs to real numbers or a subset of real numbers. Subset of real number it can be natural numbers, it can be whole numbers, it can be integers, it can be rational numbers, it can be anything. Okay, so it can be a subset of R or it can belong to R itself. But real valued functions, it is real numbers. So this is what is given in the definition. A function which has either R or one of its subsets on its range. Range means output. Okay, so this is called the real value function. If its domain is also either R or a subset of R, domain also it is going to be input. Okay, domain and the range, it is going to be real function. Only the range, it is going to be real valued function. Okay, so this is the difference. How are we going to use this? We'll see later. Okay, now example 12. Let n be the set of all natural numbers. Define a real valued function. F of x equals 2x plus 1. Real valued function output should belong to R or any subset of R. Correct? Only the output. Using the definition and complete the table below. So I have x equals 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm just writing the tabular column downwards. And I want f of 1, f of 2, f of 3. So this is going to be my y. F of 1 na, this is basically f of x. That is what they are asking you to do. So f of 1, when I substitute 1, I'll have 2 into 1 plus 1. I'll have 2 into 2 plus 2 and plus 1 when I substitute 2. Then I'll have 2 into 3 plus 1. Wherever I have x, I'm substituting with it with the values. This is basic, okay? And then 2 into 4 plus 1, 2 into 5 plus 1, 2 into 6 plus 1. Simple calculation. 2 into 7 plus 1. So what are all the values? It is going to be 2 plus 1, 4 plus 1, 6 plus 1, 8 plus 1, 10 plus 1, 12 plus 1, 14 plus 1. So the values are going to be 3, 5, 7, 9, 11, 13 and 15. Okay, so you can simply fill the tabular column with these numbers. So 3, 5, 7, 9, 11, 13, 15. So basically all odd numbers. Okay, very easy. Idala real valued function. Now what is the range? Range is going to be 3, 5, 7, 9, 11, 13, 15. So this is a subset of real number which is going to be odd natural numbers. Okay, please copy.